Hey, good morning, E-Techians. I got a couple more example problems I'd like to show you that will help you do the resistors in series and parallel problems that I gave to you last time. So I want to show them to you now. Suppose you had well, here's what I gave you last time, right? So if you had something like this where you had resistors in a bunch of resistors in series, right? You would and this is R1, R2, and R3. I'm not going to put any numbers in here because I'm just reviewing right now. But if you had a circuit like this, what's the total resistance of these all together? Well, first thing you need to recognize is because there's only one path through all of them, are they in series or are they in parallel? If there's only one path, there's only one current, that means that they are in series. And when you have resistors in series, we showed that you just add them together. So I would just add these, whatever, like 10 ohms, 15 ohms, 30 ohms, whatever it is, add them together and you've got your total resistance of the circuit. But also if we did this, if you have a something like this where you have R1 and R2 and R3. Here we have three resistors, and are they in series or are they in parallel? Well, they are in parallel because they all have the same voltage drop. See, this would be, let's say this was a 12-volt battery. This would be, everything up here is at 12 volts, everything down here is at 0, so 12-volt drop, 12-volt drop, 12-volt drop. When resistors all have the same voltage drop, and when the current can split up between them, like here's all the current that comes out of the battery, and some of it goes through here, some of it goes through here, and some of it goes through here. And so when you would add these three currents up to get the total current, then these things are in parallel. And to get the total resistance, we said it was kind of complicated, but you just go 1 over R1 plus 1 over R2 plus 1 over R3. And that's what we did yesterday. And then once you know the resistances, you can figure out the currents, and you can figure out the voltage drops across each resistor up in here and everything. Okay, but now I'm going to show you two circuits that have resistors in them that are both in series and in parallel. And I'm going to show you how to figure out the total resistance of them. So let's take a look at this. Here's a 12-volt battery. And let's say I've got a 3-ohm resistor right here. And over here, I've got 2 resistors. And this would be, let's say this is a 4-ohm resistor, and this is a 2-ohm resistor. And let's give these names. Let's suppose this is R1, this is R2, equals R2, and this is R3. So suppose that, let's take a look at this circuit, and I'm going to ask, I can ask lots of questions. What is the total resistance of this circuit? What are the currents through each resistor? What are the voltage drops across each resistor? Well, here's what you do. You look for things that are in series or in parallel. Now, if I take a look at R1, is R1 in parallel with R2, just with R2? And the answer is no, because R1, you have a voltage drop from here to here of 12 volts. But here R2 has to share the 12-volt drop with R3. So these two do not have the same voltage drop, so they are not in parallel. And the same could be said with R1 and R3. Okay, is anything in series here? Well, R1 is obviously not in series with R2 and R3, but if you look at R2 and R3, you can say, well, I have a current running through here, and these 2 resistors have the same current flowing through them. And thus we can combine these into one resistor. And because they're in series, I can say, hey, and I'm going to call it 2, 3. R2, 3. That means I've combined resistor 2 and 3 into one resistor. It's just going to be R2 plus R3. because they are in series. And we said that resistors in series just add. So it would be 4 plus 2. That would be 4 ohms plus 2 ohms. And so R23 would be 6 ohms. Okay? But we're not done yet. We want to know, what is the total resistance of the circuit? Well, now I'm going to redraw the circuit. And I know it's a lot of work, but it's not that bad. Okay. It's not that bad. It just takes me a second. Here's 3 ohms. That's R1. And now I'm going to draw this as if it's one resistor. It's one 6 ohm resistor. That's R2 combined with 3. And I think you can see, if you consider this just as one, R1 is parallel with the combination of R2 and 3. These two resistors are in parallel. So now I can say R total, because now we've got all the resistors. If you want to call it R1 combined with 2 and 3, you can do that. That's going to be equal to 1 over R1 plus 1 over R2 added to 3. Or R2 and 3. Okay, so this isn't bad. This is 1 over, well, this is 1 over 3 ohms plus 1 over 6 ohms. Now I can get a common denominator. I'll just finish the problem really quick here. 1/3 is the same as 2 over 6 ohms, right? So 2 over 6 plus 1 over 6 is 3 over 6. So this would be 1 over 3 over 6 ohms. And I think you can see that if I reciprocate and multiply this, this would be 6 ohms over 3, which is 2 ohms. And that's the total resistance of this whole circuit right here. This whole thing is 2 ohms. Now you could use that total resistance to figure out how much current a 12-volt battery would put out. Once you know the total current, you can figure out, well, you could figure out what these currents are, and from there figure out the voltage drops and all the other things that we've done. But that's how you get the total resistance for this circuit. We got one more. So this was where you had 2 resistors in series in parallel with 1 resistor. Well, what if we had this instead? Same 12-volt battery. But now let's suppose that I move my 3 ohm resistor out here. We'll call that R1. And then here we've got R2 is 4 ohms. And then R3 equals 2 ohms. So we have a 3 ohm resistor, a 4 ohm resistor, and a 2 ohm resistor. Now, same thing. What's in series, what's in parallel here? Well, you can't say that R1 is in series with R2. Why? Because the current, it's not the same current. When you get right here, some of the current is going to go this way, but some of the current's going to go this way. So it splits up. So they do not have the same current, so they're not in series. And obviously R2 and R3 are not in series with each other. So there is nothing in series in this circuit. Is anything in parallel? Yes. Look at these. Okay, I got 12 volts here. I'm going to have a voltage drop here, but all this stuff is going to be at some lesser voltage than 12. And all this stuff is at 0. So if you look at R2 and R3, they both have the same voltage drop, and they both split up that current that feeds into that junction. So therefore, R2 and R3 are parallel to each other. So I'm going to combine R2 and 3. So R2 and 3, we're going to combine them. But I have to combine them in such a way that they are in parallel. So I go 1 over R2 plus 1 over R3, because they are parallel to each other. And so now I can plug in our values. 1 over R2 is 1 over 4 ohms plus 1 over 2 ohms. Get a common denominator. Okay, this is like 2 over 4 ohms. And so R23 equals 1 over, well, what's 1/4 plus 2/4? That's 3 over 4 ohms, which is equal to 4 ohms divided by 3. So the combined resistance of R2 and R3 is 1.33. Don't put a bar over there, just round it off, ohms. So there's R2 and 3 combined together. Now I can redraw the circuit again because I've combined two of the resistors. So here I've got R1, which is 3 ohms. But now I've taken these two and combined them into one. And these have a resistance of 1.33 ohms. So now the current that goes through R1 is the same as the current that goes through the combined resistances of 2 and 3. So therefore R1 and R23 are in series with each other. Another way of looking at it is that R1 is in series with the combination of R2 and 3 together. Okay? So we know that the total resistance for resistors that are in series are just R1 plus R2 and 3. So the total resistance is going to be 3 ohms plus 1.33 ohms. So the total resistance is 4.33 ohms for that circuit. And then once I know the total resistance, I can figure out the currents, and then I can figure out what the voltage drop is from here to here. And once I know that, I know the voltage drop here, and I can figure out the currents. I can solve the circuit. I can figure everything out that I need to figure out. So I hope that this makes things clear. Let's just review real quick. You know, if all your resistors in series are in series, you just add them. If all your resistances are parallel, you just add the reciprocals and reciprocate that answer to get your total. But if you've got two in series in parallel with one, combine those two in series first, and then add them together as if they are in parallel, as shown here. And of course, if you have one in series with two that are in parallel, combine those two that are in parallel as we showed, and then redraw the circuit, and you can get the total resistance. So it's kind of complicated, but that's those are the problems that you're going to have to solve on the worksheet, which are here and here. And hey, Philip, if you're here today, and Matthew, if you're here today, I've got here your worksheets right here. So your sub, give them to you. So look at number 4. I've got two that are in series right here in parallel with this one. And here I've got two in series with one in parallel. Really, these are almost the same exact problems. But look at this. Look at this one. I've got two in series, two in series. Combine these, and now you've just got two in parallel. And then you can figure out all this stuff based on that, on all that information. So anyway, that's what you need to do. Good luck. I'm going to give you about 30 minutes of class time to get this whole worksheet done. And we will grade it on Monday. Have a great day. Have a great weekend. I'll see you on Monday. Bye-bye. That is all.